So good afternoon, everybody, and great to see in the attendance list that so many of you around the world has joined us today in this virtual OSCAR workshop. My name is Astrid Linder, and I will moderate the workshop today. And first of all, some practical things. Everybody is muted due to that we have around 225 registered attendees, so you will not be able to use your microphone. However, you will be able to use to write questions during the whole workshop, and we will, after both the virtual presentation from the virtual project, from OSCAR project, and from the update on virtual testing sessions, have question and answer slots, 15 minutes for each. And then, in addition, since already there have been many requests to have more discussion, we will stay on after 4:30 until 5 o'clock. So an additional 30 minutes we will be around, and so please hang around and continue to get the discussion going if you're interested. So see if there were any other practical thing. No, I think that was it. So first out today is the virtual project, and I'll see if I get the possibility to show my screen. No, not yet. So I hope you see the presentation of the project virtual and brief in front of you. So I hand over, as you see, to myself, because I'm the coordinator of the virtual project. This is the full title of this project is, oh, I get things in my way, Open Access Virtual Testing Protocols for Enhanced Road User Safety. It has a duration of 4 years. We started 2 years ago. We have nearly 7 million euros from the Commission. We are 15 partners around Europe, and you can see them outlined here, highlighted on the map, from 9 different countries. So our aim is to reduce loss of life and health in the road, in road crashes for all road users. We also aim at share and foster knowledge, and that's why we develop the tools that we do in open source. And we have in focus to identify and promote protective innovations using virtual testing, and the tools there in terms of the human body is, of course, human body models that we do in the open source format. In addition to the partners that we also have, bear with me, oh, it's a bit slow on my computer. Anyway, we also have a broad international collaboration. Because this is a task like this is, of course, something that not even we 15 partners can do on our own. So we rely on broad collaborations. We have partners here, as you see from the world, in an advisory group, and we all have also close collaboration with different research institutes and companies, so and academia, of course. So this put us in a global context when it comes to the work that we are doing. We have a vision that by 2030, in-Euro protective performances of new cars will be assessed for both women and men. The benefits of this is, of course, that we will then have an inclusive crash safety assessment. We will also be able to identify the best performing innovations already in new cars, as it is today. When it comes to how they work for men and women, we have to wait 10 plus years before in-Euro statistics tells us this. And by having a more inclusive assessment of safety, we would improve safety for everyone. We are organized, as you see here on this slide. We have 3 different user cases or user groups, and we have in work package 1 we develop all the test protocols and the open virtual testing platform. In work package 2 we develop the open source human body models. In work package 3, we have a whole work package where we look at occupants in vehicles and in novel seating positions for occupants, where for the future, where we foresee that we will go into autonomous vehicles, of course, and the whole way through there, we will have a broader range of seating positions and also positions of the chairs. Then we have a work package on vulnerable road users here, pedestrians and cyclists. The other vulnerable road user group, motorcyclists, is funded in the same funding scheme, but in a separate project. So we are 3 projects funded in one scheme, and one is virtual, the other one is OSCCAR, and the third one is the one addressing motorcyclists. And then we also have a work package addressing the standing occupants in public transport, and looking at using the tools that we have developed in the vehicle safety areas and apply those in the area of safety of the public transport users. And then a whole work package on cost benefit assessment. So with that, I will leave over to the work package 1 and Arne Keller, that will tell you about the open virtual testing platform that we are developing there.
Yeah, thank you very much, Astrid. So let's see whether I can share my screen. So I hope that is visible now. So the OpenVT platform, that's, as Astrid mentioned, the core content of virtual work package 1. Now, as Astrid, so now my webcam stopped. Oh, okay, thank you. As Astrid mentioned before, in virtual we're developing quite a set of cool things. We're developing state-of-the-art human body models, but also a whole environment, a whole ecosystem around them, like tools, test protocols, and so on and so forth. But what actually makes them so particular is the fact that all of these results are going to be available free and open source. Now that means they're not only free for every interested individual or institution for download and for use, but people can also take those models, they can modify them, they can customize them, and they can eventually even contribute to the further development of the models. Now, saying that these things are free and open source while they're just sitting on your personal computer is one thing. The other thing is actually making them available free and open source, and that in a project in the size of Virtual takes a dedicated infrastructure, which is the OpenBT platform. So if you want to put it like this, the OpenBT platform is actually Virtual stored to the outside world. Now, from the concept of the OpenBT platform, there's actually basically three core functionalities. At first, the OpenBT platform is, so to speak, our workbench. That means development of the virtual contents is actually happening on the OpenBT platform itself, and also the collaboration between the virtual members and also collaborators from outside of virtual. Then at the same time, the OpenBT platform is also a dissemination vessel. That means the virtual products are directly brought to the global user community from the workbench. Then the third pillar is sustainability. The OpenBT platform is also meant to be the basis for survival of our project results beyond the actual project duration. Now to the technical implementation. The OpenBT platform is already available as a GitLab server on virtual.openbt.eu. Now, if you browse to this address, then you're going to see this this screen where you have on the right side a sign in and register functionality. There you can just go and register with your email address. I would like to encourage you all to do so. It's for free and it's very quick. And on the left, you have a couple of links to, for instance, manuals and guidelines, the OpenBT wiki, and an overview of the public contents that are available to anyone on the internet. Speaking of public contents, so here's an overview of what is already there and what will be available soon. So for the moment, there's only the original Viva model and a cost-benefit analysis tool available to the general public. This is already very useful things, but there's a lot more to come. Within the next few months, we're actually we're expecting all of these things listed below to be available. So of course, we're all waiting for the first release of the Viva Plus models, which Johan is going to present in the next talk. Then there will be pre-crash tools for assessment of vulnerable road users. There will be a post-processing tool, validated seed models for adult seed and child seed. And that's only the next few steps in the next couple of months. And towards the end of the project, there will be even more things. So you can expect that actually the OpenBT platform within maybe half a year or a year from now will be a very, very rich toolbox to anyone interested in road safety testing. So that brings me to a question: what will happen once the project Virtual is over? Once the active duration will end in the year 2022? And the idea for that is actually already in the genes of the OpenBT platform, because the OpenBT platform has a full open source workflow. That means not only you can do the classic software development workflow where a development group, in that case the virtual members here displayed on the left, are working on some content such as the virtual models and are then disseminating that to the global user community. But also the member of the user community can download the contents, they can do local clones and branches and actually start working on the contents. They can modify them, they can customize them. And eventually, once they feel like their further developments are any good, they can actually suggest to the developers that they integrate their results into the original version on the platform. That's called a merge request. And if the developers feel like this makes any sense, then they will very likely accept that, and the new modifications will become part of the generic version on the OpenBT platform. That means essentially there's a true community-based approach, and that can actually that does not necessarily even need the virtual project anymore to survive at some point, but it actually lives from the user community that also becomes a developer community now. And So therefore, I would like you all to participate actually in that, become part of the virtual community, become part of the user community, but also of the developer community. And then at some point we can together as a community make the virtual models become better and better, keep them evolving, and maybe in the future we can all contribute to make road traffic around the world a little bit safer. Yeah, so that's essentially a short impression of the OpenVT platform. And at this point, I would like to hand over to Johan Iraeus, who is going to present to us the Viva Plus models. So, yes,
thank you, Arne.
Thank you, Arne. Johan, before you continue, I would like to remind all the attendees that you can type your questions in the questions tab of GoToWebinar, and we will try to answer as many as possible in the Q&A sections. Thank you.
Okay, thank you. So regarding work package 2, some of the specific project aims directs the development of the open source human body models in work package 2. So within the project, we have undertaken to create models of the average female and the average male in both seated and standing positions. We will also use 3 test cases to demonstrate the virtual tool chain. And injuries frequently seen in these load cases will implicitly direct the focus areas of the human body models. And the test cases that we have in the project are seated occupants and whiplash injury. It's protection of vulnerable road users, and that is pedestrians and cyclists, and also fall initiation of standing occupants in public transport. The first step here was to define what is an average female and an average male. And actually, this is a non-trivial task, even just considering stature and body mass. And depending on your population of interest, this average can vary quite a bit. So in addition, these numbers change over time. So after long discussions, we decided to use the recommendations of the Schneider and co-authors in their 1983 study, which is the foundation for all current human body models and crash test dummies. An important upside with this choice is that the models can be directly compared to what is available today. And on the other hand, one downside is that these anthropometries will not directly correspond to any current population. We can, for example, here see the world population that are named NCD risk in the figures. And in general, these are smaller. And we can also see the current US averages named NHANES 2011 and 2014 in this figure. And these are more obese compared to the Schneider recommendations. And then in addition to the mass and stature from the Schneider study, we also added the age to the model. And this age was based on the average of the European adult population. Traditionally, human body models have been developed using medical data, and that is, for example, CT data, MRI, laser scans from a single individual. In this project, we do it a bit differently. With the help of our friends at UMCRI, we instead use geometries that are averaged over a population. So in addition to the outer shape, also the geometries of the ribs, the pelvis, the femur, and tibia are population averages. The rest of the body parts, where we don't have averages, they are still based on a specific subject, and that is the same that was used for the original Viva model. We then create one baseline model, and that is the seated average female. And the reason here for choosing the average female as base model is partly technical, but also partly political. And that the reason, or the message here is that it's time to put females in focus. Using mesh morphing, we can then create derivative models like the standing female and the seated male. And the difference between the base model and the derivative models is mainly the node file with the nodal coordinates. And this means that when it's time to do bug fixes or model enhancement later on, these changes just need to be implemented in the base model. Morphing human body models to other anthropometries is not a new thing. However, morphing seated models to standing is not so common. And one major problem when doing this is mesh distortion in the soft tissues around joints that experience large rotation during the transform. The Viva Plus base model is created from scratch with mesh morphing in mind. So we have tried to orient the mesh flow to minimize the areas with poor element quality. However, this is still work in progress, and we do not know how well this will work out in the end. Currently, the derivative standing model is created by first running a morphing script for 15 minutes and then spend about 4 hours of manual process to improve element quality and also to depenetrate all contact definitions again. And the end result is a new node file with the coordinates of the standing model. And again, the only difference between the base model and the standing derivative is the node file. The legs, including the knee, the rib cage, the pelvis, are modeled in great detail to allow for strain-based injury evaluation. The cervical spine was already detailed in the original Viva model and has been carried over to the Viva Plus models. The base and the standing derivative models are now finalized for beta testing, and so far we have mainly focused on model robustness. Here we can see 3 of the robustness load cases. From the left, we have a driver in the frontal oblique crash, in the middle, a rear seat passenger in a frontal crash, and to the right, a driver in a side impact. These load cases are rather severe and test the model robustness rather than its biofidelity. So during the rest of the project or the rest of the year also, we'll focus on model validation and in parallel continue to improve other aspects of the base model. And now my colleague Johan John will talk a bit about the Viva Plus and open science.
Thank you, Johan. Now that we have seen some details of the Viva Plus development, let us now take a step back and look at the bigger picture of how Viva Plus contributes to open science. The global transition towards open science was highlighted by UNESCO last year, having open science as the theme for the World Science Day. The EU Open Science Initiative Forster gives a nice definition of open science. Open science is the practice of science where others can collaborate and contribute, where research data and research processes are freely available under terms that enable reuse, redistribution, and reproduction of the research. These are some of the features of Viva Plus to enable open science practices. The models are licensed with lesser GPL version 3 for unrestricted sharing and usage. We developed the models in an open repository with Git version control, and the developers use GitLab collaboration tools for a develop in the open workflow and for quality control. Finally, for reproducibility of analysis workflows, we use Python-based dinosaur library and notebooks like Jupyter. The value of open science, open source, comes with the users contributing back to the library that they received freely and openly in the first place. When you contribute back and others in turn can make use of your contributions, it creates a positive value chain that sustains good science. As an example for Viva Plus here, users with all roles and expertise can contribute with their knowledge and experience. You're welcome to contribute to Viva Plus. And now this was a summary of the Viva Plus, and I hand over to our colleague Corina. Klug.
Okay, so now we have heard a lot about the models itself and of the general project outline. Now, what I'm going to present you is now the first more precise application case. So one of the use cases, it is the vulnerable road user protection. I hope that you can see everything, and I also have the control of my screen again. So what we plan to do here in work package 4 of the virtual project is that we try to bring together a passive safety assessment of vulnerable road user protection as well as active safety protection. So we want to bridge this gap, and we want to have standardized virtual testing protocols that are really where we can really make an overall assessment of these two different types of protection mechanisms. And these standardized virtual testing protocols will be based on the open source tools that are developed throughout the project and that are available on the OpenVT platform. So this is just an overall picture that we were drawing when we were trying to get our first ideas on how this could look like. And the idea is that we have the pre-crash simulation and the in-crash simulation hand in hand. So we do have virtual testing scenarios that are used for the pre-crash simulation, and then based on this result, we then do our in-crash simulations with the open source Viva Plus models to finally get our total assessment. And to make sure that what we do virtually has something to do with the real cars on the road, we also define the validation with physical tests for both the in-crash simulation as well as the pre-crash simulation models. In virtual, we are not focusing on cars only. We also have a use case where we focus on tramways that are equipped with AAB systems, where we also try this overall assessment, exemplary for some specific cars equipped with specific vehicle safety systems. And we focus on pedestrians and on cyclists. And very important for this whole project, always on the 50% male and the 50% female, as we're also really interested to investigate the difference here. We started with an accident analysis as other projects did before, but now, of course, with our specific focus. And overall, we were able to analyze more than 4 million pedestrian and cyclist accidents in the analyzed sample, as the virtual partners had access to multiple accident databases. We had in-depth databases as well as macroscopic databases, so that in the end, we got a quite nice overall picture from Europe. Based on that data, we then classified our conflict situations. We applied here clustering based on the moving patterns of the pedestrian or the cyclist, as well as of the vehicle, as it was published by Lindman et al. Earlier. So our aim was here to determine the probability of a specific conflict scenario on European road. And then after that, we also derived for each of these types of conflict situations a probability for motion sequence parameters. So that means, for example, the speed of the vehicle, the speed of the vulnerable road user. And then we also added some additional environment parameters, so that in the end, we have a catalog of virtual test scenarios with related probabilities. So for each type of conflict situation and each combination of speeds and environmental conditions, we do have an overall probability as we have it now on the streets. This is then used as an input for our catalog of virtual testing scenarios between vehicles and vulnerable road users. Based on this, we built our virtual test scenarios that you can see here on the bottom, and we can run pre-crash simulations with the virtual pre-crash tool, which uses OpenPath as a simulation platform. So it's also fully open source and will be fully available. When we apply then a generic AAB system or a specific AAB system of a specific car, we can then derive the number of avoidable scenarios, as well as we can also identify those cases that are unavoidable and lead to a final collision between the vehicle and the vulnerable road user. And based on that, we can define our collision scenarios, which means now really an impact location and an impact velocity, which is the basis of our future accident scenarios for in-crash simulation, because we think that we only need to simulate or that we specifically need to simulate those cases that are not avoidable by the active systems. In our in-crash simulation, we use now the models that Johan has showed you before. So we use the open source human body models, and we use a validated vehicle model to then perform our in-crash simulations. We then apply post-processing routines of the HPM results with the open source post-processing tools that we have to finally get an injury probability for the specific body regions we are most interested in. So the aim is that in the end, we do have an overall, for example, femur fracture that consists of the probability of a femur fracture for a specific collision scenario. And we also know how likely it is that this collision scenario will happen with a specific active safety system. And that's how we try to make an overall assessment true. If you're interested in reading more about the results, we also have some publications that have been published already. Some are pending, some are in preparation. And now I would like to give you once more the opportunity to ask your questions and hand over to Astrid, who is now going to answer them or redirect them to those they are dedicated to. Thanks a lot.
Thank you very much, Corina, and all the other presenters from the virtual project. As you rightly said, Corina, I will, as a moderator, formulate the questions and direct them to in this case, to the different speakers from the virtual project. And first out is a question to Johan. When will these models be available? What would you say?
Yes, so they are in the beta phase now. So just in a couple of days, actually in 2 days, we will have a workshop where we will have some invited beta users that will start testing the models. If they will go publicly online at the same time, I do not know right now. I think we have to come back to that later. But that is the first, at least semi-public release.
Yeah, great to know, and great to know where the models are in these phases. And as you said, we do have 2 more years in the virtual project, so of course we have a substantial further development here. But there are we open up for others to contribute, and we have quite some time for further development. Thank you. And that leads on to a question for Arne about how can I contribute to the open virtual testing platform?
Yeah, thank you very much for that question. It's actually a good question. Well, you've seen the sign up or registration link on virtual.openvt.eu. So first step is just go there, sign up. It only takes an email address and a couple of seconds work. And then you can, for any publicly available content, you can actually, there's a little button on the repository where you can ask for access to that content, and then you can actually contribute. You just download the content, start modifying them, and eventually you can push them back to the platform and ask the developers to integrate that into the actual generic version of the platform.
And we should
in case there's anything unclear, just go to the manual and guidelines section, and there's an issue tracking board where you can ask questions that goes directly to the platform administration. That is, for instance, myself. And there you can ask any question, and we're very happy to help you with whatever problem.
Mm-hmm. Thank you for that, Arne. And it's worth highlighting again that we have put jointly substantial thoughts and actions into making it both accessible, but also to have structures in place to take care of feedback and all good suggestions that are out there. Thank you. Let's see here if we have some more questions. We have a structure here where we try to sort the questions that we get. So we get some in batches, and others will. So there will be questions that comes from several of you, or specific question. If there is one person that has a specific question, then that will be highlighted and addressed to a specific speaker. So I'm now looking at the system, the part of the system here where we get questions going, and I wonder if we have something more that should be addressed now, or we will take it later. So I just checking with Christian, which is take care of the technical part. Is it time for us to go to the next to the presentations for Oscar, or?
I think we have a few more minutes to answer a couple more questions. In the chat, Corina has written a few questions.
Okay, I don't have them.
Shall I try to help out?
Oh,
so
sorry.
There is another question to Johan, and the question was if the morphing scaling methods are also going to be delivered together with the models, or only the final models?
That's a good question. We are aiming to deliver that together with the final models. So the idea here is that if you do any updates on the base model, you should rather easily be able to create all the derivatives. And for that, you need a morphing code. So of course, we're striving for that. So far, we have used some code that we cannot put available to make available to everyone. But we will see if we can rewrite that code in a new format, so we can share it later. But for this time, for this beta release, we are not sharing that code. But the aim is to do that later on in the project. Yes.
Thank you for that, and thank you, Corina, for stepping in, because now I see it was hidden for me, the questions here. So the next question is actually to you. It's formulated like this: if dinosaur is being used in virtual, will there be two separate codes in the end, like one for THUMS and another one for the open virtual testing?
Yeah, so no, the idea is of course not to have to have the same code on two different locations. That would not make sense, because then it's difficult to merge also the improvements. So Dinosaur will stay on the THUMS GitLab webpage, because we have the whole history and everything there already. But what is available on the OpenVT platform are all the post-processing routines that come with our protocols, as well as all the definition files that you need for the Viva Plus model, so that you really have the whole package that can be then used. But Dinosaur is then like your library that you install to use those procedures that are available on the OpenVT platform.
Excellent. Thank you for that clarification. And here is another one for Johan again. The Viva Plus model attracts attention here. Will you provide morphing scaling methods for the Viva Plus models, or during the time, or is it only for the final models?
So that question felt quite similar to the previous one. So if I answer a bit different, but not different answer. So the morphing code, morphing or scaling code, whatever you call it, to scale the base model into from the average female to the average male and to the standing derivatives, that we aim to provide at the end of the project. However, we have not planned to create a general morphing code that can scale the model into any anthropometry. So, but in this project, we have said that we are addressing the average female and the average male, and we have them in seated and standing postures.
But the structure is such so that could be done. Of course, not everything will be done in one project. So the structure is such that this can be done. So we're providing the basis for that, right?
Yeah, and I mean anyone will be able to morph this model using, for example, Piper later on. One reason we are not using Piper is that we want to have a really well-controlled morphing from the base model to our derivatives, so we can do that more or less automatically. And we think that the best way to do that is to have a script that we have full control of. Whereas if you want to explore the models further away from the average male and average female, then you could, for example, use Piper to do that.
Yeah, good that you also mentioned the Piper too, and the work done in Piper, because we also show that we address children, and there we use the Piper models, right?
Yeah.
Which is also open source, and earlier EU funded project from an earlier EU funded project. Very good. Thank you for that, and for going into the details a little bit more when it comes to the models. I see that the time slot for virtual is coming to its end, and I'm checking with Christian here. Is it time to go to the next point in the agenda?
Yes, it's okay. Time to present the OSCAR project.
Yes, so I leave the word to the OSCAR project.
Okay, hello everybody. Werner Leitgeb from Virtual Vehicle is speaking. I'm setting up my stuff here as well. I hope you can see my slides here. That's the idea. Okay, I hope it's showing the correct slide. Welcome everybody. Welcome to this workshop also from my side. We organized together with the virtual project. Thank you everybody for joining in and for participating. Thanks for switching off the webcam as well. Today I'm going to present a quick overview about OSCAR itself, and then together with my colleagues from Mercedes, Chalmers, University of Stuttgart and BAST, we're going to lead you through this session, and also have a questions and answer section in the end afterwards. So same rules as before apply. Astrid is going to ask the questions later on, and you can type and write them in. Okay, a very quick overview about OSCAR. I think most of you will be probably aware. It's a European funded project, partner project of Virtual, same funding time and scheme in general. We are originally planned for a 3-year project and having 21 partners within Europe and also in China here. Any more information, please go to the OSCAR webpage down here and you get more information here. The general ideas about OSCAR is dealing with needs for future occupant safety, especially in the oncoming event of autonomous vehicles here. And therefore, it's absolutely important to understand future accident scenarios that passenger cars are going to be involved. We are going to demonstrate advanced new protection principles necessary in order to safeguard occupants in future autonomous vehicles and new sitting positions. Therefore, we are going to develop and further develop and contribute to the development of a diverse omnidirectional and biofidelic and robust human body models. Establish and integrate a virtual assessment framework in order to look at all these kind of complex scenarios and the advanced protection principles for the occupants themselves. And as today we're talking mostly about virtual testing, this project perfectly aims itself at contributing to the standardization and harmonization of virtual testing procedures. Many OEMs taking part, many relevant tier ones, and research institutes, universities, and academia taking part here. So yeah, we hope to contribute a lot to this standardization process in general. So a little bit in more detailed and up-to-date updates what we are currently doing. OSCCAR is developing several protection principles with the main focus on looking at HBM applications. So we're looking at protection principles in order to safeguard occupants in sitting positions that are relevant for future automated driving scenarios. And within OSCCAR, we are looking at two parts here. The one is going to adapt and improve the restraints in order to care for the new boundary conditions. And the second area we're looking at is repositioning the occupant towards a conventional sitting position prior to the crash. So in order to do that, we are going to look at the omnidirectional occupant itself and its needs and develop protection principles. Therefore, we are having 6 protection principles we are going to look in more detail. That is a swiveling seat, an inertia-driven seat, so that's seat rotation. One reclined seating that focuses especially on the anti-submarining devices, a mushroom airbag for living room conditions, a reclined seat, and also a far side use case we are going to look at. A little bit more in detail on 2 protection principles, especially relevant to this workshop today, as it was going to be presented at ICOBI. So I'm going to focus a little bit on those here. The one is the swiveling seat, where the occupant in general is forward directed using either a powered system or inertia-driven system around the Z-axis. That's one of these principles. And the second one that is available already on the ICOBI webpage is a study on reclined seats and putting the backrest up into a normal backrest position in order to safeguard the occupant in this case here. Okay, a little bit more into updates what is currently happening in the department in the area of integrated and comparable assessment. We are currently collecting and working on common simulation input criteria that allow for comparing results, not generating equal or similar results, but comparable results, so that you are not comparing apples to pears, but actually it's the same input conditions here. One of these important areas is the HBM seating procedure and seating posture and seating position in the end, where we are currently developing a software tool that allows for a reproducible seating position here. As was already mentioned in the previous presentation, the common and comparable assessment is absolutely paramount. And also OSCCAR is building on the dinosaur tool that Corina mentioned before. Also updates are being done within OSCCAR so to allow all the represented solvers to being addressed. That is in this case Lestina, VPS, and Madimo. So very important part here. And yeah, this is necessary to guarantee a standardized solver output so that you can compare and the assessment and make the assessment in the end for different solvers. And now to the main focus of this part here, virtual testing. OSCAR is developing virtual testing and assessment procedures in various aspects here. That's the most important and most pressing needs. I'm going to expect also some input from our further speakers further down the agenda of today. There was a first proposal already published on virtual procedure on environment validation here by EGAS at last year's VDI conference Fahrzeugsicherheit, very important. And yeah, apart from that, harmonization efforts are being driven a lot over here in this project. And we are also going to prepare and working on a homologation test case demonstration. A little bit putting everything into the bigger picture here. In order for virtual testing, virtual assessment, and virtual homologation being effective, all the necessary areas of the use case and occupant protection need to be considered. One of these areas is the future accident scenarios, and within OSCAR, generic load cases were developed for future relevant accident scenarios. And in addition to that, a methodology to estimate the generic crash pulse for these crash configurations, so that at least here within OSCAR we can have relevant crash pulses based on state-of-the-art finite element vehicle models in our case here. Third part, as mentioned before, definitions and relevant terms, in this case together with THUMS user community, harmonization on definition of terms was done. I'm not going to read through that, but a big suggestion here on how to define verification, validation, calibration, and then certification of models of environments and so on needs to be done. And the suggestion for this can be found on the OSCAR homepage and as well on the THUG web page. Link is down here. And last but not least, from my side here today, in respect to virtual testing, we're going to provide a homologation test case demonstration within OSCAR. This should be an exemplary procedure for future virtual approving using HPMs. So an important part here, we're going to use here extrapolation of hardware test data and valid test data to a new virtual only test case. So this is a test case where no fallback option to doing it in hardware exists any longer. OSCAR here will focus on the reclined forward-facing occupant position, and Andre will talk about that a little bit later and a little bit in more detail. Important here, we're going to demonstrate a method that delivers comparable results. As I said before, we are going to use different models, different solvers, so we are not going to produce identical results, but comparable results with the same input. As we assume, or as we hope, and as we strive for, this will be the basis for credibility and acceptability and acceptance of virtual testing in general. And yeah, OSCAR is also going to look at this load case continuously from the pre-crash to the in-crash phase. So the complete accident and relevant accident phase for occupant protection here is going to be dealt with. Okay, going to hand over to Christian, who's going to introduce the following speakers and content.
Yeah, Werner, many thanks. Warm welcome also from my end. I would just like to briefly introduce the speakers now of our more technical or biomechanical oriented session. So the first speaker again is Johan Iraeus from Chalmers University. He will talk about the consolidation, or maybe better alignment, of strain-based rib fracture risk evaluation. Next will be then Lennart Nölle. He's PhD student at Stuttgart University. He will present us an approach to evaluate also minor injury risk in the pre-crash phase. And our last speaker will be Jason Fice. He is postdoc at Chalmers University, and he will show us the current status of the OSCCAR validation catalog for active HPM or HPM with human behavior. So, Johan, again, your turn.
Thank you. So, the goal of this subtask is to provide guidelines how to use tissue-based injury criteria to get robust and consistent results. And for this, estimation of rib fractures will be used as a demonstrator in this presentation and in this project. As you probably all know, traditionally chest deformation together with deformation-based risk curves have been used to estimate chest injury risk. And this is called a global injury criteria. In contrast, a tissue-based or a local injury criteria estimates the injury risk based on the local tissue loading. And here we will use element strain as the tissue measurement related to injury risk. Shortly, the procedure to estimate tissue-based rib fracture risk can be summarized as a simulation, including the human body model, is carried out. Then rib strains, time histories are plotted for each rib. The signals are post-processed to remove potential artifacts. The maximum strain in each rib is converted to the fracture risk using a tissue-based risk curve. And then finally, the fracture risk for all 24 ribs are combined into an overall risk for the whole rib cage. This procedure was originally presented in a AAAM conference paper by Foreman and co-authors in 2012. While the global injury risk based on chest deformation is rather insensitive to numerical noise, the opposite is true for tissue-based criteria. And the reason is that numerical problems on element level may result in strain artifacts. And these strain artifacts will then manifest itself as unrealistically high strain values. An example you can see here in the middle figure. And if we do not account for this, this will directly lead to an over-prediction of the tissue-based injury criteria. Next slide. Next slide, please. Back one slide, thank you. Okay, so in addition, as with all models, it is essential that the human body model is properly validated. And here this means that we need to show that the model accurately predicts element strain for a wide variation of load conditions. And in particular for the validation of rib strains, we propose to use a set of validation load cases at different complexity levels. From the left here, we can see well-defined single rib tests to check rib stiffness and rib strains. In the middle, we have a tabletop test to check rib cage stiffness and strain distribution. And then finally, to the right, a sled test to check the kinematics and rib strains in a more realistic environment. Next. There are many different strain measures, as most of you probably know, and the strain can be evaluated at different locations here in the cortical bone. So in the original publication, neither the strain component or the location is mentioned, and there is currently no consensus about how to use this. We propose to use the maximum principal strain, which is also called the first principal strain, as the strain component, and to measure this at the outer surface of the cortical bone. And the reason to evaluate the strain at the outer surface is because rib cortical bone can be regarded as brittle. So as soon as a fracture starts at the surface, the rib will fail. Also, possibly elements adjacent to attachment points of, for example, discrete elements or beams or whatever that is used for modeling muscles, and other areas with unphysical loading can be included from post-processing. Next. As mentioned before, tissue-based injury criteria are sensitive to numerical noise. So if left untreated, this will lead to an overestimation of injury risk and non-robust evaluations. So we propose to use some type of filtering, for example, a time gradient filter. However, this is still work in progress that we have to come back to later on in the project. Next. Finally, the original proposed tissue-based risk curve was defined as an empirical cumulative distribution, which is the jagged line in the figure. The intention with this was good, that is to highlight the few subjects that were used to create this curve. However, the implication was that a small change in strain can lead to a rather big jump in injury risk. So that is not favorable. So instead, we propose to smooth the risk curve by fitting the data to a parameterized Weibull distribution, which is here shown as a red curve. And with that, I will hand over to Lennart for the next topic.
Thank you very much, Johan. Okay, I hope everyone can hear me. And I would like to talk to you about a method on how to evaluate injury severity to the muscle tendon unit. And the reason why we were thinking about such an evaluation in the first place was because we wanted to develop a method to evaluate the risk of passengers sustaining minor injuries due to the function of the pre-crash safety systems which were shown before, for example, the rotating seat. We wanted to find a way to make sure that the passenger does not sustain injury to his musculature, his or her musculature, because of the rotation itself, for example. The injury criteria for the muscles themselves were based on one type of injury mechanism, which is the strain injury. And the reason for that is because hill-type muscle models, as they are often employed in active human body models, are modeled as 1D truss elements, and therefore they have no volume, so other types of injuries such as lacerations or contusions cannot really be modeled with these types of muscles. The injury criteria themselves should also include a gradient of injury severity. So we decided to define 3 injury thresholds for minor, major, and rupture injury, basically. And we tried to find values which would correspond to the yield strength, ultimate strength, or the material failure of a generic engineering material, just for example, like steel. Next slide, please. Thanks. Through literature research, we were able to identify thresholds for the tendon, a completely relaxed passive, and a 100% activated skeletal muscle. You can see the threshold values themselves in the table below. The only thing I want to say about that is that the tendon injury thresholds were based on the strain the tendon is put under. This is easily measurable, while the muscle injury thresholds are based on the tensile force needed to pull the muscle to failure. 2 questions arise from that, the third one being, how does one obtain this tensile force? Because it is not readily available in literature, but from comparison of biomechanical data sets, we came to the conclusion that this tensile force can be estimated as 3 times the muscle's isometric maximum force output. So this tensile force would be 3 times F max. Next slide, please. Thanks. The next question would be that I just showed you threshold values for a completely relaxed and a completely activated muscle. But of course, if you take a look at the stimulation, which is biofidelic, you will get activation values in between these 2 extreme threshold values. And the way we calculated these the injury threshold values between completely passive and completely active was simply through linear interpolation, depending on the activation. You can see an example of these threshold values in the diagram in the bottom left for the muscle and in the bottom right for the tendon, just so you have an image on what these thresholds would look like. And the assessment of injury severity according to these injury criteria would basically just be a post-processing step. The forces or the strains acting on the muscle or the tendon are compared against these threshold values. Next slide, please. Thanks. Here is an example on how this can be used in practice. Our colleagues from Mercedes-Benz India were so kind as to provide us with simulation results from their side. And here you can see the simulation is the rotating seat of projection principle 1. And there has been done an injury analysis for the semispinalis captis muscle in the neck, highlighted in red in the bottom right. And you can see that the comparison with our injury thresholds showed that no minor injury occurs. Next slide, please. This is just a quick overview to show you that this holds true for other muscles as well, even for seat rotations in 200 milliseconds as shown in the upper row, and for the slower rotation of 350 milliseconds shown in the lower row. Next slide. Yes. Now I will change topics a bit and give you a really quick overview over some plans we had for the future, namely on how to adapt control algorithms as to model population diversity and mobility impaired people. And for that, we decided on 3 groups of passengers we would like to take a closer look at. The first one being elderly occupants, which can be characterized by an elongated reaction time dependent on age and gender. And for these passengers, we would introduce a stimulation signal delay, so pretty straightforward. Same goes for wheelchair-bound occupants, where one could simulate the reduced lower limb control by not stimulating muscles in specified limbs. And the last group of passengers we would take a look at is occupants suffering from neural diseases. There are a few which would lend themselves quite well to simulation approach. The first one being acquired neomyotomia, which is characterized by spontaneously occurring muscle activities. So this could be modeled as stimulation noise. And the second one being cerebral palsy, which is characterized by a reduced inhibition of the stretch reflex. And for this, one could change the settings of a reflex controller, which is length-based, so that this defective stretch reflex can be modeled. That's all from my side. Thank you very much for your attention, and I will now hand over to Jason Fice from Chalmers University of Technology.
Thank you, Lennart. So what I'm going to talk about today is a validation catalog that can be used to validate active human body models in pre-crash scenarios. So we want to look at active human body models because it's an important part of the OSCAR goals. And it was decided that it would be important to be able to compare the active human body models from different groups in the OSCAR project by having a common set of validation data that we could all validate our models to. So in this validation data set, we specifically looked at pre-crash data. That was because active musculature potentially has a more important role in these pre-crash events. And then to look at the validation for these scenarios, we did a literature review. We found 25 different volunteer experiments, but we selected experiments specifically so that they would be reproducible for validation of human body models. Specifically, we looked at 3 categories of pre-crash maneuvers. So to start with, frontal acceleration or braking, lateral acceleration and lane change, and combination. For each of these 3 scenarios, we wanted to have at least 2 test cases that were actually in the vehicle or in a vehicle in order to have the maximum applicability to real-world situations. but we also wanted to have one load case that was performed in a laboratory, which allows for potentially tighter control of the loading conditions and potentially more easily modeled. You note for the combination load case, we only have the 2 load cases because there was no suitable combined braking and lane change maneuver in a laboratory setting. So these are the cases shown here. I'm not going to go over each one specifically, but note that these cases were picked because we could get the loading conditions were well defined, the boundary conditions could be modeled, and also the kinematics were well captured to be able to validate human body models. So, and as I've referenced, the seat is, in order to be able to validate these cases, we want to have boundary conditions that are well defined. So an important part of being able to have well-defined boundary conditions is to have at least part of the seat and environment modeled. And that can be really difficult if you don't have access to geometry. So for our load cases that we selected, we have seat models for three seat models that are applicable to multiple load cases that were selected. To start with, I'll speak a little bit about the Chalmers seat model. So we had the geometry for the seat was based on a Volvo supplied seat model, and we morphed a generic seat to match the geometry of the Volvo seat model. And then we tuned the foam material properties to match physical indentation tests that we performed on this seat. And this seat also includes both standard seat belts and pre-tensioner seat belts. Next is the VIF/TU Graz seat model. So in their physical seat, it was based on a 2012 Mercedes-Benz, but this seat was stripped of its foam and outer layers and simplified pieces of foam, and then a artificial leather was placed on top. So the geometry of their model was based on scans of the physical seat, and then the foam material properties were taken from physical material testing of the foam in the seat. And next, the Siemens seat. So this was based on a racing style rally seat. So the physical structure of the seat hopefully is a little bit more simple and more easily modeled. And the seat belts used for the seat were a 4-point belt with inertial reel on the shoulders. So this data set is available to the OSCCAR partners currently, and we hope in the future to be able to share this data or this validation data set with a wider community. And that's everything I have to share with you now, and I think I'm passing on to Andre again.
Okay, yeah, thank you. So I will talk about virtual testing, which is the final part. One slide back. So this is about the full virtual testing approach with human body models, which has been developed in our virtual testing work package together with some other partners that you can see here who contributed to this part of the presentation. And the focus of my presentation today will be a vehicle interior model certification process by validation, and why this is so important for this human model-based virtual testing approach. I will explain you now. Okay, next. So before going into this, I would like to start to talk a little bit about what is actually the motivation for virtual testing in general. Also looking at some previous initiatives. In other projects, for example, EU project Inviter, it was only about replacing existing real testing based procedures by virtual testing, and the focus was only saving costs. Another motivation for virtual testing could be to extend the scope of protection, for example, by adding new load cases, new conditions, varying test parameters using other dummies, but also this can all be done by today available dummies and test devices. And this is a hybrid approach, we called it, which is combining virtual testing and real testing. But what we want to do in OSCAR is really use human body models where we cannot use dummies anymore. And what we will address in OSCAR is what was mentioned before already, new seating postures resulting from autonomous driving vehicles, also taking into account user diversity, looking at different occupants. So if we don't have the appropriate dummies available, we want to use human models. And this is also what you can see quite nice in this figure. Vehicle safety is getting more and more complex. The occupant as a test tool needs are increasing. And at some point in time, we cannot cover this anymore by dummies, and we'll need to go for human body models. But there's one aspect we have to think about. If we use really a full virtual testing approach with human body models, we have only the occupant model available virtually. So somehow we need to make sure that the vehicle interior model that we are using is also validated. And that's why we need a vehicle interior model certification procedure based on validation. Because in the final assessment, there's no possibility to check that the vehicle model is valid, because we cannot compare it to a real corresponding test, because we don't have the corresponding real test tool. So what we do in a full virtual approach with human body models is not a hybrid approach, and there's no fallback option if we cannot validate the vehicle model. Thinking about that, we developed a process which you can see here. There's a first phase where the vehicle model is developed. That's done by the vehicle manufacturer. In the case of occupant safety systems, it's only the interior environment model, so everything that's in contact with the occupant. Some code-specific requirements, quality assessment requirements will have to be taken into account. Some internal experience about validation, but in the next step, that's a more official validation process. Some load cases have to be defined, validation load cases, which can be carried out with the model, and at the same time by a real test. So we need this test configuration, and for that, use some objective rating procedure to validate the vehicle interior model. With this certified model, and what we can see here on the top, also a certified and agreed human body model needs to be available. So we have a vehicle part of the model, the environment or interior model, the human model, and can combine this in a new assessment procedure, which is done completely virtual according to a standardized process, and will be used to evaluate the vehicle safety in a new condition, for example, a load case representing a new seating position. Looking a bit more in this model certification phase, how it looks like. So we need to define validation load cases which are representative of the new loading condition, which can be a crash test, sled test, or subsystem tests. And we also need to define the validation tool, which could be a currently available dummy, but also some kind of modified dummy, if it's not possible to use the current dummy, or could be also a new simplified validation tool or dummy. And based on that, we need some objective correlation procedure, which is also important because we might want to look at very specific validation measurements and channels which are specific for the load case. And based on that, we need to define thresholds, which are on the one hand demanding, but also achievable. And this should take into account the real test scatter. Applying this to our OSCAR homologation test case, which, as Werner explained before, will be a frontal impact case with a highly reclined seating posture. And the test tool will be a human model representing an average occupant, including some improvements in the soft tissue layer. The interior validation load cases that we in OSCAR proposed as a first step are sled tests using the SOAR dummy as possible validation tool, and tests have been done in different conditions, for example here in the upright and reclined position. And the sled tests have already been performed in the project, and we use this for interior model validation, also looking at 3 different codes to see if this can already also work in different codes and gives comparable results. So that's what we did so far and what we are still planning to do in the remaining part of the project. We want to compare SOAR and HVM simulations in the validation load cases to get an idea if these sled validation load cases are appropriate or if we need some additional validation load cases, and also looking at the SOAR dummy if it's actually a good validation tool or if something else would be better. We also want to evaluate possible metrics like COA or ISO and try to define some possible thresholds, taking into account the dummy variation response, also the variation in vehicle components, and based on further tests with higher repetition, we want to get an idea of the test scatter in the real tests to define acceptable thresholds. And finally, in the end, we want to bring this together to make some kind of draft proposal for this kind of vehicle interior certification procedure, which then could be used in a full virtual human body model-based type approval or homologation test procedure. Okay, and with that, I conclude my presentation. I think hand back over to Werner.
Yeah, thank you, everybody. Thank you, everybody, for keeping the time. Just as a last slide, please visit OSCAR webpage where you can get all already available and publicly available deliverables. And yeah, I also put the links to the current IRCOBE papers and related IRCOBE papers down here. So I would like to hand over to Astrid or Corina, or Christian, in order to use the remaining time and ask us more, maybe 1 or 2 questions. Thank you.
Thank you very much from the OSCAR project. Great to hear about. I will start with a question to you, Werner. This is a question from Christian Kleinbach, and this is how it goes. Is the HBM seating method about defining the H point with respect to a given seat, or is it about seat deformation prior to the actual crash simulation?
The seating procedure is a general procedure in order to pose a human body model in any kind of seat. The posture itself you need to derive from whatever kind of tool you want or every kind of method you want. So this could be either a PHMS, could be, I should have put my webcam on, no, sorry. Could be either PHMS, could be a Ramsey's data, or any other kind of posture you want to put it in. The model itself is placed then with this method into the seat you have. I hope this answers the question.
Thank you very much. Let's see. Here I have a question from Jonas to Lennart. Okay.
Yeah, sure.
Yeah. Could you please explain how the strain thresholds were derived?
Oh, yeah, sure. The strain thresholds for the tendon, I guess, were derived from data found from rat tail tendons. There was an experiment done on the regenerative quality of rat tails, and during this research they arrived at a stress strain curve for a rat tail tendon material from which we could derive our threshold values, and the threshold values were in accordance with the damage they also were able to see at the tendon itself. So that's how we arrived at the thresholds for the tendon damage in regards to strain.
Excellent. Thank you for that. So I'm looking at the system for questions. Oh, here we have one. Very good. This is a question to Andre. Could the hybrid 3 dummy also be used for validation?
Yeah, actually, we have been thinking about that, and the idea really is for validation is to load the interior, the environment of the vehicle, like the human body model would do in the final assessment simulation. And if the hybrid 3 can do this, then of course the hybrid 3 is maybe more robust, it's cheaper, and then it could be an option. And finally, we want to compare the SOAR dummy in these new loading conditions to human body models, or also PMHS when they become available. And actually, some publications might even show that the hybrid 3 is for some loading conditions as biofidelic as the SOAR dummy, or even more. So that's, I think, something that's still open, and maybe hybrid 3 and SOAR are not good, but we need some maybe simpler validation dummy or tool, like I think in the virtual project you are working on. So I think that's a good question, and it's a possibility, which but an answer at the moment I cannot give, but it's really an option to think about.
Yeah, and you are very right. That we are developing these evaluation tools for the low severity rear impact scenario and testing case, and so that might be the stage that we would need to take for other impact directions in the future. Interesting. Thank you.
Yeah. Mm-hmm.
We have also a question here to Christian Meyer. Does the OSCAR also focus on head injury risk assessment?
Can you recall the question, please?
Does
Again?
OSCAR also focus on head injury risk assessment?
Yeah, OSCAR is also focusing on head injuries. We have the colleagues from Strasbourg also on board, which you might know, Remy and Caroline and Frank are dealing with the head models finally, and they will. I think we had also web session just a few weeks ago where they reported on the current status of their head model and also the neck model finally.
So we can look forward to hear more about that in the future. Excellent. Thank you for that. And with that, I would say that it's time to switch to the next presenter, which will be Michiel van Ratingen. And now we will do it a little bit different when it comes to question and answer sessions, because Michiel has to leave shortly after his presentation. So there will be a short 5 minutes for questions to Michiel. So please, if you have specific questions to Michiel, type them and we will address as many as possible after Michiel's presentation. So I hand over to you, Michiel.
Thank you, Astrid, and hello everyone. Thank you again for inviting me to give a short update on Euro NCAP's work on virtual testing. For those that were in Florence last year at the workshop, you remember maybe that I gave a presentation on the reasons why Euro NCAP is interested in virtual testing as a concept to add to the consumer rating program that we have here in Europe since 1997. So I'm not going to talk a lot about the reasons why. I think during the presentations that I just heard from Virtual and OSCCAR, a lot of the motivation stuff was also talked about. What I want to give you today is a little bit an update of what happened since last year. Of course, we have COVID and the situation totally different than when it was a year ago. But nevertheless, we made some progress. We had some meetings and made some decisions regarding how we want to go forward on this topic. So it's talking a little bit about far-side impact, which is the pilot that I mentioned last year as one of the options. We decided to go with that, and then the test tool definition, and a bit about the quality control and checks, which of course is something that is maybe not a big concern from the research perspective on human body models, but is of course fundamentally important when you talk about assessing vehicles for consumer information and the reliability and the trust that you may have or may not have as a consumer in the work that we do. So a little bit about the motivation. I think Iraeus already touched on many of those. Just to say here that it's not just crashworthiness that we are interested in. We are also interested in virtual testing for active safety and even for automated driving, simulating traffic and vehicle interactions and radars and stuff like that. When you include that in the mix, there are not only potential benefits in terms of more realistic models and remove hardware limitations of dummies and diversity that you can introduce and robustness, but also things like over-the-air update, which becomes then possible if a vehicle manufacturer would update software on the vehicle, that you can actually simulate what the effect is of those software updates on a general benefit of a safety system. So there are actually quite a few potential benefits of going in this direction. Of course, we all understand that there are huge challenges when you really want to do that in a standardized way as we want to do it. So for crashworthiness, our approach has been to really adopt what Iraeus just sort of pictured or imagined, starting off with a physical test that we have defined for a particular safety system. And then the test that follows from that would actually be the baseline for our virtual test scenarios. That means that we have to start with a validation phase, as Andre was mentioning. I mentioned it here, digital twin, just to emphasize the fact that this would be exactly the same setup as described in the protocol of Euro NCAP, however, virtually. So it would actually not use the hybrid 3, it would use the hybrid 3 computer model, or it would not use the WorldSit, it would use the WorldSit model. And of course, the vehicle environment is the virtual environment that the vehicle manufacturer has access to. He actually developed that in its own vehicle development process. So that is available to a large extent. So assuming that this validation will work, we then have the basis with the digital twin to start adding different load cases that we are interested in from our perspective. Can be for robustness reasons, can be because we want to investigate other genders, can be because we are investigating different speeds or different angles of impact. Things that are, of course, obviously doable physically, but will actually cost a lot of extra work and a lot of extra components and actually be quite difficult to do in reality. So this virtual load case, and I'm looking at the first green box here, could actually still use dummy models, maybe in a different seating position or even scaled to some extent, or just the boundary conditions of the load case itself could have changed there. So a step further would be actually to take the dummy model out completely and to start using virtual models, virtual human body models, that actually have a much more realistic behavior, where we can actually study some sort of injuries much more specifically. So ultimately, the concept as we are now seeing it actually would use the physical results, but then also would be complemented with either dummy model results and or human body model results. So of course, if we look at the current state of the art, dummy models have been around for much longer than human body models and used more consistently over the past years. So it's likely that we will focus in the first step on virtual dummy models, and then as we go forward, we will actually start to use human body models to complement the full assessment. Now, ultimately, the whole assessment can take place on the physical results and then dummy model results and human body model results, and maybe eventually we get to a situation where we can actually skip the first green box here, the ATD model load case, and go straight into human body model results complementing physical results. So that's how the concept works. Of course, when we're going to do this, we are confronted with a lot of issues. I mean, what I've just heard from Virtual and OSCCAR, many of these topics are actually the key cornerstones that we need to have to actually build this system. Things like vehicle model control, how do we validate vehicle environments, what load cases should we define in terms of giving benefit to the assessment overall, which is more a Euro NCAP question by itself. But also, how do we handle data? How do we keep the quality? How do we score ultimately? And maybe centerpiece at the moment is really how do we make sure that the virtual occupant specification can be controlled in a certain way. Of course, to go in this direction and to really move the needle forwards would actually mean that we have to accept some limitations at the moment. We saw a presentation by Corina that looked into integrated safety solutions. That, of course, is possible. For the moment, we have basically kept that out of the discussion and really try to focus on the methodology development based on passive safety only, just to make it more achievable. Also, what we are clearly not there for, and I think we have to refer to other organizations worldwide to do that, is really to further development the human body models in terms of injury risk assessment capabilities. So we really are standing on the shoulders of the universities and other organizations worldwide that are pushing this forward. We are not the organization to bring more biomechanical levels into the human body model tools. So why did we go for Farsight? Farsight is a relatively new test procedure in Euro NCAP. Was only introduced a year or two back in terms of monitoring, and this year we'll start really adding it to the rating scheme. It was originally foreseen to do that on a SLAT basis, which is, of course, a simplification of a full-scale test and therefore quite attractive from the modeling point of view, because we can actually relatively easy or even more easy actually model this accurately than a full-scale crash test. It calculates faster and there are better ways to control the boundary conditions with an input that is given on the SLAT, right? So the SLAT procedure is basically using a world set dummy on the driver position, and then gets exposed to a Farsight loading pulse, MPDB pulse, MDB as well as pole pulse are studied here. And we actually look at the kinematics of what's going on in the dummy and whether countermeasures such as center airbags are doing a good job in keeping the dummy in place, but also protecting against injuries in the chest and head and neck and so on. So that is the starting point of this procedure. One of the things that we discussed already in the group is the protocol as we have defined it today for the purpose it has sufficiently accurate and sufficiently specified, well specified, to give us enough input to actually do a proper validation. And of course, there are recommendations here to add different sensors, more precise measurement of the dummy position, etc., to the protocol to be able to have the possibility to accurately make this digital twin in the computer environment. Once you have done that, I think the question here is, what are the relevant virtual variations that could actually benefit the safety of the consumer if we would do that as an addition to the physical test? And of course, there you immediately come up with the current limitations of computer modeling. And so you cannot really change a lot of the environment immediately because there are calculation issues that you will end up having if you do that. So we can think about things like delta V, even vehicle variants. So you can actually start changing some of the body variant specifics. You can look at different anthropometry. So you could potentially use the world set 50th dummy model and replace it by a 5th female dummy model. You could look at seating position as well. So all these things, of course, if you would add that to the assessment, would ultimately give more confidence that we are looking at a robust technical solution from the vehicle manufacturer's point of view, rather than just having optimized for a world set single size dummy in a single pulse, basically. So that's really why we are looking at this case in particular. And of course, ultimately, we can, once we have figured out how to do it, we can start thinking about other type of virtual environments. So when it comes to human test tool definition, let me start with the ATD model itself. Here already, if you talk about the practicality of using dummy models, you will immediately end up recognizing that there is a lot of variation in ATD models, even though the dummy is pretty much well specified through ISO in this case with the world set dummy. There are different codes, there are different code versions, there are different model suppliers. Some are commercially available, some have in-house modifications. Then you have different model versions that are being used. There's different generations of the models. And in many cases, these models are linked to the vehicle program that the manufacturer has used. So they start a program with a certain variation or certain model version and will not change their dummy model during the development of the process. So these are things that we need to consider. We cannot basically say, you have to do this virtual testing with a specific dummy model in a specific code, because it will actually create huge bottlenecks at the vehicle manufacturer side or the supplier side to actually make these calculations work in the end. So we chose to go in another way. Rather than specifying a particular dummy family models, we say we want to go to a certification catalog that vehicle manufacturers need to run with their models to show that the quality is assured, basically that they meet an average performance. Now that may sound familiar. It's quite similar to what Coherent is doing in the human body models for pedestrian safety in Euro NCAP. But of course, in this case, it would be specifically for near and far side load cases, including some simplified restraint interaction, which of course are quite important to have. So the first question, if you do that, is what are the load cases? Do we have sufficient biomechanical background to define these cases? What about simplified restraints? And what about the correlation requirements? So how good need the model be to be accepted for the use in Euro NCAP's virtual testing process? Of course, ultimately, this is a manufactured declared process. The dummy models are used by them. You could also think about ultimately the supplier of the model doing this for the vehicle manufacturer as part of the release of a model. If we talk about human body models, and that's of course more interesting for today, we sort of see the same thing going on as we do for dummy models. However, we are a little bit behind in terms of in terms of where we are with human body models, and there may be other things to take into consideration as well. Our feeling is that a lot of work has been done already. A lot of work has been done on virtual and OSCCAR, and even outside of Europe, I think in the US, in Japan, Korea, China, there are initiatives to look at this. And so we feel that it's very important to bring the knowledge together in a roadmap to really see, okay, can we agree on the most fundamental things that need to be taken care of if ultimately we're going to apply human body models in a process like this. This human body model for virtual testing is a framework that just started, coordinated by Corina and Philip Werner from BMW. Very transparent, everybody can cooperate, but it's really the intention to address some of the things that are here on the screen. So common anthropometry references, biomechanical basis, validation levels, harmonized human body model application methods, and of course, ultimately leading to transparent human body model requirements for future virtual testing applications. So again, a lot of these components are in the making. We've seen that today in the workshop. What we really want to achieve is that this is not a local initiative. The industry and everybody else is best served if we can agree common standards around human body models, as we have been doing for dummies in the past. Good, so I want to finalize really with an overview of quality control and check. So ultimately, what is really important for Euro NCAP is that we can actually have trust in the process that we are starting, and that we can actually defend computer modeling to the consumer, that the consumer cannot say to us, well, you have just accepted some simulation computers. What does it mean for my vehicle? I think that trust question is quite important for NCAP, and therefore we need to think about how do we control the flow of simulations that lead ultimately to acceptance of the solution. So you see here the three things that I talked about. So the occupant model itself, the vehicle environment model that needs to be validated, and then ultimately the assessment models, those that are the variations of the protocol that add the real world robustness to the assessment. So first of all, the occupant model I discussed already. So it is going to be the supplier of the model or the OEM to run these simulations against certified catalog. At the moment, I think we should consider that there may be additional certification needed for a specific vehicle, for a specific restraint system that we haven't seen before. So I think we should not close the door immediately and say certification catalog is the only thing needed. It could be that you have a very novel restraint system where the human model or the dummy model even is not really validated against yet and could have problems, and therefore additional certification could be required. Ultimately, it's going to be Euro NCAP saying that, have you met the certification acceptance criteria? Yes, then you can basically proceed to the next level, which is the vehicle environment model. And of course, the models at that stage should sort of be frozen or locked, so to speak, to make sure that there is that you're not optimizing the vehicle, the dummy model or the human body model as we go forward. So vehicle environment model is, of course, more complex. It would be the OEM or the systems integrator that runs these simulations. It would be ultimately Euro NCAP to verify based on validation acceptance criteria. And of course, if you talk about validation, you talk about material validation, component validation, system validation. Those are the common levels that everybody is aware of. The question, of course, is how much of it is really needed from the NCAP verification point of view. Last but not least, again, you can lock ultimately what you have to some extent, and then only allow the variations that the protocol prescribes in terms of load cases, so variations in boundary conditions, seating positions, etc., etc. Of course, a lot of these things are now being developed by OSCAR, Virtual, and elsewhere. I think what is clear to us already in the working group is that we need to verify the occupant model, we need to verify the vehicle environment model, and we need to look finally on the assessment model results to include that into the rating. So these are things that are clear. What maybe is not so clear is what are we going to do with, let's say, additional vehicle manufacturers certification of models, or are we going to really need to go to material validation levels and component validation levels in ultimately accepting a validated vehicle environment model? So these are things that are still open in my view, where we need to see is what is reasonable, what is sufficient for getting trust in the process, just the top level, or do we need to go deeper to some extent? So with that, really, I wanted to stop my presentation. This is as far as we come. There are a lot of discussions underneath, which I don't want to go into detail about. But I think this gives you quite a good indication. So virtual testing for us offers many opportunities, but everybody knows that there are important challenges to overcome when you want to do this, certainly from an NCAP perspective. I think what we can clearly report on is that the industry and the academia and Euro NCAP really are working together now to see if we can move the needle and we can make a feasible methodology that can be used for crash protection systems in the way that we foresee it. And then we've chosen the far side impact situation as a starting point because of its complexity and also its current limitations in the physical sense. But the last year, we really focused on model quality control, which I think is fundamental in achieving the trust, which is, of course, one of the more important parts in Euro NCAP's work. Back to you, Astrid. Thank you.
Thank you very much, Michiel. It's great to see how we move forward here. And unfortunately, we don't have time for many questions, but I want to take the time to have one question at least, and because we got some questions about timelines here, and I think that is of course very important for many of us. And will human body models be integrated into the Euro NCAP far side rating is one question. Another one is if virtual ATDs will be implemented first, or will you go human body models? Do you want to elaborate on that a bit?
Yeah, so as I explained, the fundamental principle is to include both dummy models and human body models, but it will really largely depend on whether we can stabilize the human body models for a use that we can really rely on, whether we control basically the human body models. So I think that the process that I just mentioned, this virtual testing for human body model, or human body models for virtual testing, is going to be fundamental in achieving that point. So as far as the timing, it was 2024. I mentioned that last year. Of course, we have added a year of delay due to COVID, but I'm pretty confident that by 2025 we will have this as a procedure in Euro NCAP, including human body models.
Thank you for that, Michiel. That gives us a clear goal to work towards. With that, we will have to move to the next speaker, which is Marcy from IIHS. And again, thank you very much, Michiel.
Thank you.
Hi.
Hello.
Very good. I hand over to you.
Thank you. Good afternoon and good morning, everyone. Thank you for joining us today, and thank you for your interest in our research. Today, I want to share with you a brief outline of IIHS's research goals for whiplash, and in particular, virtual testing. And again, as Astrid said, my name is Marcy Edwards, and I'm a research engineer at the Insurance Institute for Highway Safety.
I think we were having some trouble showing Marcy's screen, but now it should be working.
Okay. Does it look okay?
We see 2 slides now.
Yeah, let me try again.
Yeah, while Marcy is getting this to work, I can share with you that we had a substantial learning curve, all of us here, and but of course you never know what happens in the last moments, even though we have practiced quite a lot. We still see two sort of screens.
Okay, let me.
And I think Marcy got up today at 4 a.m. to try that out, or something like that.
I did, and it still doesn't work.
Oh, here it is.
There we go.
Oh, now it's perfect.
Excellent. Okay. All right. Sorry about that. Okay. So first, I want to share some brief background on our current whiplash evaluation program, which is some of the motivation for the direction that we'd like to go in virtual testing. So IIHS has been evaluating seats for whiplash protection since 2004. And in that time, we've seen that better rated seats show a greater reduction in insurance injury claim rate compared with poor rated seats. And in this chart, you can see that good rated seats reduce injury claim rates by 11.2% compared with poor rated seats. However, as you can see in this chart, almost all our current model year seats are rated good, and yet in our real world data, we still see a range of injury claim rates. And so this tells us that our current whiplash rating program is no longer able to differentiate between worst performing seats in better and worse performing seats in the real world. So this has led us to pursue further whiplash injury research. As many of you know, we've been working to identify meaningful ways that we can update our protocols that will affect real-world whiplash injury. This involves encouraging active safety technologies like AEB and driver assist features. It also includes encouraging robust seat designs that can protect many occupants. And specifically, we are looking at alternate crash severities, varied occupant positions, and a range of occupant sizes and sex. In this presentation, I will only be focusing on the passive safety aspects of our research. So as I just mentioned, we are planning to encourage robust seat designs by researching different crash severities, occupants seated out of position, and a range of occupant sizes and sex. For different crash severities, we are researching the addition of a higher severity physical test like the Euro NCAP 24 km/h delta V pulse or the J NCAP pulse. For out of position occupants, we have 4 research goals. We want to look at realistic out of position scenarios. We want to look at alternate positions that can be achieved with the BioRid physical dummy. We want to understand the feasibility of evaluating these alternate positions with BioRid models. And we want to understand if human body models represent human occupant out of position scenarios better than dummy models. And for researching the range of occupant sizes and sex, we want to understand whether alternate size or female dummy models improve the correlation of test results to real-world data, and if human body models offer more options for evaluating a variety of occupant sizes. However, for the near term, we are only going to be focusing on these 4 tasks still highlighted. First, I'm going to briefly share some about our physical testing research for different crash severities. For this group of 8 mid-sized vehicles, we have conducted tests with the IWPG pulse, the J NCAP pulse, and the Euro NCAP high severity pulse. Then, using their respective rating schemes, we made correlations with our insurance injury claim rate data for these vehicles, and we found some promising correlations. On the vertical axis is plotted the percent of maximum score for each respective rating scheme. And since everything is rated good in the current IIHS test, you can see that we don't have any correlation with our claim rates. However, both the previous Euro NCAP scoring system, the current Euro NCAP scoring system, and the J NCAP scoring system showed correlations that we think are meaningful. However, since we've only evaluated 8 vehicles from one vehicle class so far, our next step is to conduct a similar assessment on the mid-size SUV class. When that research is complete, then we'll have a better understanding of whether one of these alternate rating schemes might correlate better with our injury claim rate data. So next, our next topic is whiplash research in the assessment of alternate occupant positions. So for this research, we envision 3 initial phases. First, we want to identify real-world out-of-position scenarios from naturalistic driver data. And we want to investigate using the physical BioRid dummy in alternate seating positions and the biofidelity of BioRid in these positions. And we want to research the feasibility of evaluating these alternate seating positions with BioRid computational models. First, we would like to conduct research to understand how current driving behaviors affect interactions with the modern generation of seats and head restraints. For locations and scenarios that we've identified as common to rear impacts, We plan to use naturalistic data to observe occupant behaviors at those locations, for example, looking down at a phone. And then we want to categorize how these behaviors affect occupant position relative to the seat and head restraint. Then we plan to conduct research to understand out-of-position scenarios that can be achieved by the physical BioRid dummy. We hope to use the physical dummy to validate simulations, so we want to choose target positions achievable by the dummy. And finally, as part of our research goals, we want to understand if we can develop a process to use seat and dummy models to reliably predict BioRid dummy response for an out-of-position scenario in an automaker-developed seat model. To do this, we focused on 3 tasks. 1, verify that the model can represent the physical BioRid dummy for the out-of-position load case. Then, develop a method for assessing the fidelity of the automaker seat model. And finally, compare simulation responses to hardware responses for the out-of-position condition. In order to verify that the BioRid model can represent the physical BioRid dummy for the out-of-position load case, we plan to use a generic simplified seat to compare the physical BioRid dummy responses to simulation responses for the out-of-position condition. And we will look at both the dummy kinematic response and dummy injury metrics. Then we want to develop a method for assessing the fidelity of the automaker seat model. And to do this, we want to compare simulation results and hardware results for an existing in-position physical rear impact test using seat kinematic response, dummy kinematic response, and dummy injury metrics. And then we will compare the simulation response to the hardware response for the out-of-position condition, also using seat kinematic response, dummy kinematic response, and dummy injury metrics. In this process, we hope to gain a fuller understanding of the field of computational modeling and its strengths, weaknesses, and challenges. In particular, we hope to understand the fidelity of BioRid models for non-standard seating positions. We hope to understand the resources required for this evaluation method for automakers and the hurdles they may encounter in supporting this evaluation method. We want to identify challenges in the workflow related to data sharing with automakers, validating models, and robustness of model results. We want to develop an understanding of the analysis tools and resources required to assess model results and compare them to hardware results. We want to define a process and metrics for validating an automaker seat model using a current hardware test. And finally, we want to gain an understanding about the robustness of model results by comparing the dummy and seat responses. So in order to achieve all of these goals, we hope to collaborate with automakers and modeling experts. We are very new to this field, and we are looking for help from you in understanding what's going to be required to move forward. We've outlined this plan, but we also understand that it's a process and that it may change as we move through the steps. So if you're interested in collaborating or sharing your expertise in this area, please reach out and let us know. So in summary, our whiplash research goals for 2021 are: first, assess alternate crash severities for correlation with insurance injury claim rate data. And then identify realistic out-of-position scenarios. Verify that the BioRid physical dummy and computational model can represent an out-of-position scenario. Develop a method for assessing the fidelity of automaker seat models. And assess whether FE simulation can provide accurate and meaningful representation of the physical dummy and seat response for the out-of-position load case. And that's everything. Thank you for your attention, and I look forward to your questions.
Did we lose Astrid?
Yeah, or
Oh,
we
here's Tjark.
lost Marcy. That was I only heard the last the word, yeah, the start of the final words of Marcy. So something happened there. I hope she will come.
Can you not hear me?
No, now I can hear you again. But we lost you for some time. At least I couldn't hear you.
Oh no.
Oh, okay. But there was the final word, like on the final slide. So yeah.
Okay.
But, my understanding was that you had ended your presentation for us
yes.
all.
Yes.
Yeah, okay. Very good.
I will sign off.
So then we'll go back to the original format where we have questions and answer at the end of these presentations also. So I will leave the word to Tjark.
Yes. So good afternoon. So that was one of the very typical hiccups, right? So I hope that now you can see my screen, which is, at least this morning, it worked.
But also with your notes. So wrong screen.
Yeah. So you see that this is the amazing world of electronics. Now, how about now?
Still the same.
Okay. So then one more time like this. And so I hope now.
Still
Are you saying still the notes? Fantastic. So then I think I have to do it like this, swap. And then I hope you're saying that now you can see.
Yes, royal free.
Perfect now.
Magnificent, so easy. Okay, so first of all, good afternoon to the many participants who are still bearing their time, and I can unfortunately not see, so I hopefully can keep your attention for the next 2 hours. No, sorry, after the 2 hours that the webinar started already. My name is Tjark Kreuzinger. I work for Toyota Motor Europe, and I think it's great that Virtual and OSCCAR have organized this webinar. I'm happy to have a chance to present this update on THUMS, which basically was made by Mr. Kitagawa of Toyota. So he's the expert in Japan who's mainly responsible. So if there's any mistakes, then they are entirely caused by me. So I beg your pardon in that case. So first, there is some summary on what does that mean, royalty-free at the beginning, and some background, then what we think is the best use for virtual testing for THUMS, and future updates. Maybe as a starting point, I think you all know that THUMS is now widely used for vehicle safety research already. There is also a learning that future updates from now on should be made based on the user needs primarily. A royalty-free license may bring further expansion into the evolution of THUMS because we think that future development work will need more input and contribution from real users. So first, the pure facts, what models will be available from January. And basically, it is all the 4 commercial models that are currently existing. That means version 4, occupant and pedestrian, each for the 50th percentile male, the 5th percentile female, the adult 91st percentile, and the 3-year, 6-year, and 10-year-old child models, as well as the version 5 occupant models and version 6 occupant models, 50th male, 5th female, and 95th male. So what else will we have? So we will also provide other variations which are currently not available. So, for example, there's the AF50, which has been used already for research project, but also obese occupant models. They are not included in the free model list because they would be provided for research collaborations. So what does it mean? There will be also a validation data set for each model, and other variation models for research collaboration will be basically on demand. So I'm stuck at the moment. Okay, so then what are the terms and the conditions that we are currently developing? They are not 100% finalized, but the essential thing is already decided. And that is, for example, the original copyright will permanently belong to Toyota. We will ask the users to register, and that is purely for the information of who is having that model. That is enough to show affiliation and name. We also have no problem that THUMS is modified and shared with other registered users, but it has to be always free of charge. In specific situations, of course, we can understand that commercial support between partners and projects is okay, but the model itself must be for free. So what we expect is that Toyota is informed when you're sharing modified THUMS with other users. And also to finalize, we recommend that at the moment, all existing users should switch to the new agreement from next year. I mean, already financially, that is an obvious choice. Then I'm in the next section, which is about the recommended use for virtual testing, and see that please as what THUMS has been validated for and against, so that it is clear what various test data has been described in literature related to these models and was used. So for far-side impact, you can use the version 4 occupant AM50 model and maybe with little modifications. For rear impact, we can provide also the 50th female, mid-side female, in addition to the AM50. And for frontal impact, you can use the version 4 occupant models, and in particular, aging effects on ribs can be implemented if necessary for investigating protection of elderly occupants. So version 4 pedestrian model can be used for pedestrian impacts, as it's already used following the Euro NCAP guidelines in the technical bulletin 024. Then next is version 6 occupants is primarily useful for using it in pre-collision cases to simulate muscle response. Version 7 is currently still in development, but it will be available, and that is with the objective to be introduced into automated driving, investigating posture such as reclining and similar. So one thing that is always included when we will provide THUMS is that what kind of evaluation has been done. So THUMS is available for various load cases. First, let me go into the far side impact. So it has been validated to both near side and far side impact tests. And we think that you can predict the head excursion and also the effectiveness of restraint systems in far side. Of course, also in near side, but the last word that was done was related to far side. So the use for virtual testing in rear impact, some was already previously validated to low speed rear impact tests. So that has been done against volunteer testing and PMHS testing. And this is one example case of PMHS testing that has been done. Note that there are special THUMS models with the detailed cervical joint capsules. So you can calculate, for example, the soft tissue strain as well as spine kinematics. So for this, the AM50 and the AF50 are available. For those who are not yet confused, I would like to highlight it's always mentioned if it is the 5th percentile female or the 50th percentile female. You can refer to the presentation. It will be made available, and probably Astrid will share that via some web service. So next would be for the frontal impact. THUMS was already previously validated in front impact tests. So we think that force, acceleration, deflection, and strains at several body points, as well as impact kinematics, can be investigated. The latest versions, that is version 4.1 and 6.1, have increased detail on rib cortical bones. So that means that you can better predict rib fracture of elderly occupant if necessary. So moving to pedestrian impact. THUMS was previously validated to pedestrian impact tests. So the whole body kinematics against various vehicle body types, such as SUV or sedan, has been investigated. And as I said already before, it's already available following use according to the technical bulletin of Euro NCAP 0.24. Then we're moving to pre-collisions. THUMS was previously already validated to volunteer kinematics in braking tests. The muscle controller enables to simulate posture that is changing prior to collision. And in collision, the simulation can be performed on continuous activation from the pre-collision phase. And next is within the posture. Version 7 is now under development to represent a reclined seating position. So the purpose is to simulate improved submarining behavior. So there's updates to the abdominal soft tissue by being more precisely modeled for predicting internal organ injury. And we hope that this is completed by the end of next year. So let me summarize the status. So the base models are available for possible load cases of future virtual testing. And THUMS was already validated to test data according to the numerous load cases, as I mentioned. And we expect that model certification procedure will now be developed by Euro NCAP working group. So we have already contributed and will keep contributing there in the working group, as Michiel mentioned it. We think that THUMS can be encrypted if necessary. At the moment, we do not yet see the detailed need, but it can happen in case there is an appropriate use for that. And when it becomes free, that is almost ready to use. Now let's move to the next section, which is future updates. So the current available versions are 4, 5, and 6. So namely recently released was version 4.1 and 6.1, but that is only the AM50. The pelvis dimension was modified to represent the average size male better instead of an individual person. The original model was generated from an existing person, so that is that had to be modified because the pelvis was slightly smaller than average. So also versions 4 and 6 were quite prone to submarining, so it had to be modified, as well as some lumbar spine and ribs to better represent, for example, cortical bone thickness. We will do the same modification for the AF05 and the AM95. This will be around hopefully January next year. We are also developing version 7 to predict internal organ injury due to submarining. And there we will introduce abdominal soft tissue. Full data validation will be performed using the latest test data that is relevant. We, as already mentioned, hope that will be finished end of next year. And please note that Toyota will not provide updates and supports after that. So that means we, from Toyota side, after this version 7 is released, we will stop developing THUMS in-house. Instead, we would like to transfer future updates to the THUMS user community. So TUC, which is the organization where suppliers, experts, car makers are ready now working on specific topics. And you can see in the background a little bit of the project plan that TUC is working on. So the core partners of TUC are major users of THUMS, and they know very well how THUMS will be used in the future. They know what it takes, and we expect that not only updates, but also application and standardization can be driven by TUC. So those things should be achieved under a cooperation instead of a competition, because we think that the concept of open source is very needed here. So Toyota is also involved there, of course, and we believe that royalty-free THUMS will make it work. So that concludes the presentation, and then I would be also very happy to have questions. Thank you.
Hello, Tjark. This is Amit Gupta from Humanetics. Can you hear me?
Yes.
I have one question. Really, it was a nice presentation, and
Sorry.
I have question. Hello.
Hello. Sorry to interrupt you, but the general thing is that can you just type in your questions in the question form?
Okay.
Down there, because this is what everyone did, and we already have a lot of questions. So just
okay.
to give everyone the same rights.
Sure. Okay. Thank you.
Okay. Thank you. Oh, thank you for this one, Shocks, and thank you very much for sharing both where you are and where you're going. And I think it's great to see this sharing spirit spreading. So, and before we move on to the questions, I just also want to thank Marcy for sharing the where IIHS are and where you're going. I think that was missed in the confusion of transferring things back and forth here. So great. So now we open up for the questions for these final presentations, and I will start with Marcy. This is a question to Marcy. Can it be that one of the reasons why we do not see improvement in whiplash in real life is due to the fact that users not adjust properly seat or head restraint to get the best protection from whiplash injuries?
Yes, that is for sure one of the contributing factors. I think we know that occupants often do not adjust their head restraint. And so our aim in this project is to encourage robust seat designs. And by that, I mean seat designs that don't necessarily require ideal occupant positions in order to protect the occupant.
Of course, this is where we want to move towards where the seat itself is so robust, so it wouldn't be as dependent on how you have adjusted it.
Exactly.
Excellent, thank you. Yes, and another question here, also stay on to Marcy here. What kind of collaboration and on what topics would IIHS be looking for? Are there also plans on including HBMs in the near future?
We are interested in understanding what it looks like to work with HBMs in a virtual testing environment, but we also understand that there's a lot to learn before we even get there. And so that's why we've decided to start with dummy models. And there are many avenues for collaboration in what we've laid out. We need to develop a whole plan for validation and for data sharing and analysis tools, analysis metrics. There's a lot of opportunities, and so if you have particular expertise, we'd be glad to talk to you about that, and even just sharing knowledge and experience.
Yep. That was great, and great that we have such a big audience today that to which this message is brought forward to. Very good. Here we have a question to Tjark. Will TUC take on the integration of new models contributions from the user community into future descendancies of THUMS? What is the thinking
Yeah,
here?
I think that is the intention, and I'm at the moment, Mr. Peltschuss is the leader of TUC, so I cannot speak for TUC, but actually a couple of people who we have heard already today are active members there. And so this is the community where future improvements of existing models, but also if there should be the need to develop a new generation will come from.
Very good. Then exciting times. What's the Tjark here? Will people have to pay to be part of TUC, or can anyone contribute?
I think that there is different models of membership to TUC, and I think that this is something where I do not feel that I'm authorized to talk about. So anybody who has that question, I'm very happy to provide the contact details. So that is where maybe one of the last active jobs of Toyota can be, to forward to the correct people, because this is an organization where you can also, of course, imagine that some work is done. And that means even if at all open source, it means that active contribution to improve a model means also work that has to be somehow financed, because even the biggest enthusiast has to eat.
That's how it is. Yeah, we have, of course, more questions on THUMS here. But what about THUMS in other codes? Will they also be available, and will there be fees here, or how is that going to be handled?
Yeah, so basically most work is done in two codes, and that is PEM and LS-DYNA. I think the base of all the development in most houses at the moment that I am aware of, please understand I'm from industry side, it's LS-DYNA. And I think that the vendors of codes and software at the moment who are in charge, and namely I'm talking about Dynamore, will take care that customers can also benefit from it. I think this is again the responsibility of TUC, but to my very best knowledge at the moment, there is not just LS-DYNA, but there's other codes also.
Okay, but it's not settled yet how this will work in terms of a flow, or?
So I think that the intention is that existing models that currently are for charge, and maybe you understand, you know that Toyota is has only provided THUMS in LS-DYNA. It has been adopted with the effort of other vendors and other companies. I mean, some solvers have only been used by a very small number of paying users. So that was basically always in development upon their own needs.
Okay.
What will change is that the base version would definitely be for free.
Thank you. And here I have a question to myself. Since some model will be available free of charge in 2021, how does this affect virtual? When I heard about this, I was so enthusiastic, and I still am. I think it's great that we go towards sharing. So I think that we all will benefit from this by making as much as possible freely available in the format that it works, and so on. So if anything, I think it shows also for virtual that we have chosen a path which is for the future, and that we will see more initiatives in this direction, is my hope.
I see that as a comment, not as a question, right?
Probably. Question to all, maybe to here, Marcy first and then Tjark. What is the future of human body models? How much more improvement can be expected or maybe needed from your perspective?
I think it depends on the load case a lot. I think for whiplash in particular is a challenging load case or a challenging injury because we have a lot of questions about the injury itself. And so I think there's, in order to really use them to go beyond what dummies can tell us, there's probably a lot that needs to be done. But that's part of our learning process in the next year, is to really understand what can be done with human body models in this particular injury.
So, Tjark, would you also like to comment on this?
Yeah, I think that there is basically two directions where human models will be absolutely essential, and I expect a lot still has to be done. A lot will need to be improved, and that is already inherent in the two things that I believe they're good for. One is you can go into an area where humans can never be exposed to in voluntary testing, while at the same time keeping absolute perfect biomechanics if ultimately we have the model, and that is where the model is not yet ultimately perfect enough. So you can have, beyond what the dummy can show, real injury related evaluation. And the second is just the pure number of variations at what you physically will never be able to do, hundreds of test configurations only for side impact. And with increasing computational power, that means that you can run stochastical analysis that you could never do with physical testing.
Yep. Yeah, so a lot of work to be done still. So I see the time is already up for the scheduled time. So those of you attending that needs to leave now, I will thank you very much for attending today and all the contribution. And I hope that we will meet at least a year from now in conjunction with the COBI, and that we will have similar and even deeper discussions next year. But we will, for those of you that don't have to leave, we will continue the discussion because we have a number of questions here. So we will, all presenters will be shown now, I think, I hope, if the technical part of this works, so that we can have a more as interactive discussion session as possible. And while that is getting up on the screen, there was a question to myself and Werner. And this is about how OSCAR and Virtual is collaborating, because we are funding the same scheme, we are addressing for some aspects exactly the same, and then in other ways different. We have some differences. One thought that I have when I read this question is that we are several partners that are present in both projects. So there is of course a very close interaction in terms of knowledge and sharing. And the other thing is that we have now, this is our second joint workshop, and we try to have a dialogue open. So what would you say from your perspective, Werner?
Yeah, thanks for this question. I think it's very interesting to see. First of all, I think these two projects are mostly complementary and not really doing the same thing twice. It might look like sometimes we're doing a procedure, yes, but for a different load case. So I would not say that we are doing anything double here. You mentioned already the workshops. many people are working in both projects. Johan was even representing both projects today. So I think there is no competition here. It's only collaboration, if we can say that.
Yep.
So
That's
we
how
are not. OSCAR is not developing the same things as virtual, and I hope that after both projects ended, the synergies of the results can be used in the wider community, not even in partners taking part. So that's the idea of OSCAR and of virtual, as I understand it.
Yep. Excellent. Thank you for that. We have a joint question again here about to both OSCAR and virtual, and it's about the focusing on child restraint systems. And there I can start with describing what we do in virtual, because we have that as one of the cases where we look at particular child restraints. What happens to the as we mentioned before, we use the Piper models to the children in seats, and we're looking at child restraints and how you could say robust they are in terms of how they are installed. We are not addressing misuse, but what we call misfit. So if the child restraint is correctly installed, how well does it protect the child? And we have a child manufacturer, Dorel, as one of the partners. So that's how we address child restraints. And over to Oscar. What have you any specific activity there?
OSCAR does not have any specific activity dealing with child models or with child protection, but all our methods are in principle usable for virtual evaluation of child restraints as well. So most of the things we are needing for getting a virtual protocol working are relevant also for child models. Even more so because you can put children less into tests that, for example, Tjark mentioned before, than adults. So even more critical here, and I think very relevant, but not a specific focus of OSCAR.
Yeah, but definitely applicable to child restraints as well.
Exactly, yes.
Yeah, thank you. Next question here is to Johan, and let's see. And the question goes like this: is aging considered for the geometric morphing or for rib fracture assessment?
You said aging?
Aging, yes.
Yeah. It's definitely accounted for in the morphing, and that's one of the reasons that we need to decide an age of our base model, in addition to the mass and stature that was defined in the Schneider study. So for the base model, we decided to go for a 50-year-old occupant. So that is accounted for. With that said, I can also then say that will affect the outer shape of the model, the spine curvature, and as Tjark talked about earlier, it will also to some extent affect the rib shape. So that is taken into account. What was it, the second part of the question as well?
There was a rib fracture assessment.
Rib fracture risk.
Yep.
So currently in the virtual project, we have not defined how that should be carried out, whereas in the OSCAR project, we use the tissue-based or the local criteria based on the Foreman paper from 2012. That takes age into account in the post-processing. So you measure the strain in the nominal model, and then you adjust the strain at failure based on age. So you do account for it, but not in the model.
But in the post-processing.
But in post-processing.
Yeah, that's a way of doing it. But you don't have to do everything in the model, of course. Interesting. Thank you.
I say, I think that actually the e-modulus is not very different. Aging seems to suggest only earlier fracture, not actually a stiffness difference.
Could be if you talk about like plasticity, you don't have plasticity in ribs, but the level where you reach this nonlinear phase, that one will decrease as function of age. So if you would account for that, you will probably see some different strains in the ribs. But that also means that you have to run a lot of models, one model for each age that you look into, that you want to investigate. Yeah, and we can also say that yes, there are some differences depending on age, but we should also remember that the interpersonal variation or the variation in the population is huge. So this age effect that we see is not very big compared to the total variation in the population.
Did you think of risk of injury or?
So when we say that, okay, so if we use this procedure, so that where we don't change, for example, Young's modulus, yield strain, and hardening and stuff like that, one could argue that it's wrong because that we do see some age-related effects. But I'm also saying here that yes, there are some age-related effects, but the variation, the total variation is in the population is much bigger. So.
And the effect of age?
What's that?
Then the effect of age, was that what you meant?
Then the effect of age, yeah.
Okay.
Yeah.
Yeah.
So what we do, I think it makes sense, and that we can just use the post-processing and the strain in the post-processing, and we can vary that to take age into account.
Okay, thank you for that. Then we move on to the next question, is to Andre, and is this is how it goes. When validation of interior was shown, it seems to focus on the seat. What about the seat belt?
No, actually, in the OSCCAR project, we will focus on the seat and seat belt. So the belt, is also taken into account. And in OSCCAR, we decided to use as some kind of homologation load case or pilot load case some generic environment, which consists of a semi-rigid generic seat and some production belt system, but in the end, it should be applicable to the whole vehicle environment. In case of the occupant, everything that is in contact with the occupant also can be an airbag or the interior, the dashboard. So this it has also to work for that in the end. But I only showed in a few minutes a few slides. But if you later look into our detailed work, we will also look at the seat belt and the seat and take everything into account, all of the restraints that are in contact with the occupant model.
Excellent. Thank you for that clarification. Now here next then is a question to Johan and or Arne. Is a specific software needed to use the open virtual testing platform?
Well, essentially, in order to just look at the models and download them, you only need a web browser. If you want to work with the models and with the whole open source collaboration workflow, you need the Git version control system, which is free and open source and works on basically any operating system. So it is highly recommended to work with Git if you're really diving into the open source workflow. Actually, in our manuals and guidelines sections and the wiki, there's some exact descriptions how to do that, where to download that, and how that all works. So if you're interested in that, you're invited to dive into that. And it takes a bit, but once you know it, it works. It's actually a really cool tool.
And so to the person that or persons that asked that question, there is guidance to be found and help if that isn't enough.
Absolutely.
Great, thank you for that.
Do you have anything to add to that?
Pardon?
Joby, do you have any additional comments?
Yeah, maybe something specific to the Viva Plus models or the development workflow of Viva Plus models. So on the OpenVT platform, we use a branch-based development. This is to manage all the contributions. So if you want to be a contributor to the Viva Plus models, then you would need to use the Git version control system, as Arne mentioned. And for that, you would need to install Git and learn to use the version control system. And you would find more details on the Viva Plus workflow on the documentation that we would soon be releasing. Yeah, I think that's more information in detail about the Viva Plus workflow.
And there will be a workshop in 2 days, and we're gonna repeat them maybe because we have more people who wanted to join the workshop than we have spaces. So I think there people can also learn and hands-on exercises that this is much easier than it looks from the first view.
Yeah, great connection. Thank you for that. So the next question is for Christian, and this is how it goes. Are component level improvisation on pelvis lumbar done in HPM to suit for recline seating in OSCAR?
Is the lumbar spine region improved in OSCAR to cover the reclined seating postures? Is Christian not hearing us? Then it is a question to Werner.
We cannot hear Christian, I think.
Sorry, it was muted.
Yeah. It looked like you were talking. So I thought, oh, sorry, please repeat.
This question to me, okay, maybe I'm not really the one who can answer this. Of course, we are working on. Now, I will start again. Of course, we were focusing on new seating postures, yeah, recline seating positions, etc. And we addressed this also in one of our work package 3 subtasks, where there's some injury criteria would exist also for the lumbar spine. Maybe again, I can give this question also back to Chalmers University, of course, colleagues also working on this, or several research partners working currently on the lumbar spine, especially go for a risk assessment for the lumbar spine and new postures. In OSCAR, there is currently not really an activity addressing modifications in the lumbar spine and injury criteria development. It's okay, currently we try to implement, how should I say, what's on the market here on research market.
Okay, thank you for that. Yep. Anyone else from OSCAR that want to comment on this? Oh, okay, we go move on to next question. Final question around the table. Yeah, time is clicking. From VIRTUAL and OSCCAR perspective, what is a realistic timeline for all the steps needed to use HPM in occupant safety? What do you think? What do you think will be achieved during until the next workshop next year? Shall we start with OSCAR?
Okay, until the next workshop, OSCAR project will be nearly finished. Due to Corona, we expect some delays. Originally, it was planned to finish earlier, but we expect some delays here. OSCAR will definitely not deliver the final applicability of HPMs in virtual testing, and I think that Michiel's comments on that today were already quite good and still optimistic, depending on where exactly you go and which application you focus on. OSCAR is definitely going to the virtual, taking the virtual only approach that is a little bit further into the future. So where we do not have any fallback options. This is not the case for all the other cases where you can possibly test or sub-test specific areas before. So until next year, I definitely expect us to be finished and ready with our homologation test case description and work on that. And recommendations for most of the areas we are working on currently.
Yeah, and of course a similar situation. We still have a close to a year to go when we hopefully meet next year. Some of us physical and then in additional use the online possibility to include even more people than those that will attend. But we will also be having had some further steps, of course. First of all, when it comes to the Viva Plus models that we developed, we will have a workshop now the day after tomorrow, where the first version of those will be released for a number of users that are not part of the OSCAR team or the virtual team that will contribute to the and are interested in contributing to the further development. And then we of course have the different use packages of vulnerable road users, where we will have moved forward. We're looking at standing occupant in public transport, where we have done interesting volunteer tests, where we will also be using the HPMs to model what happens to the standing occupant, and then seated occupant and both in the frontal face, but also in the rear impact. I don't know if there is anything particular to, for example, Arne, would you like to highlight something when it comes to the development of the open VT platform, for example?
Well, I mean, the OpenVT platform essentially is there and operational, and the next big step is actually to fill in more content in the first place, and actually to get the content public. And there we're, as I presented before, we're actually expecting a lot to change in the next few months. Of course, the biggest step is the release of the Viva Plus model, and so maybe that Johan is probably the person to ask about the status there, but also all those tools and seed models and so on that are going to come. So there we actually expect a lot of development, and that is happening like the next few months. So there's really a lot.
Yeah, we could have mentioned that we are developing open source seat models. One of a commercial seat that has been out on the market for a long time, and also of for those of you that have followed the development of the BioRid model and EvoRid model and so on, what is called the Chalmers seat, where we have volunteer tests with both males and females. That seat will be made, we are under the development right now, and made in an open source code and will be available. So in addition to our HPMs, like the Viva Plus models, we will have structures that you need to position the models in and to use the models with. Is there anything more we should highlight here? I'm looking at Corina or Johan or Jobin.
I think, yeah, you highlighted already the workshop that we have now, so we will be more open now for the second half of the project. So we like everyone to contribute, and we have to work on the validation load cases. We have to work on assessment criteria. So here we have to find all our requirements, and we have collected the ideas, but now we have to make sure that we can really do what we plan. Sorry, I hear a weird echo now. Okay. So yeah, and I think this will be important steps. And also Michiel has shown that earlier we tried to initiate this HPM with a testing framework where everyone is invited to contribute. And so I hope that within the next year we can encourage the whole community to work even closer together than we did in the past, and try to harmonize things and agree on standard procedures all together.
I also saw Svensson that you have joined here. Was that something that you wanted to add? I think I'm the one making the echo, so I turn off my microphone.
It might be me too who makes the echo, but anyway, I was thinking about Marcy's presentation, and I see a lot of similarities in how we think when it comes to rear impact and the type of parameter changes and so on that we want to test, and also that we want to test additional injury assessment, injury criteria, if you like, that are tissue-based, you can say, so that we, apart from measuring what you can measure in a crash test dummy, we will try to assess things that we believe might have something to do with injury mechanisms, and that we can measure in the human body model in a way that isn't possible with a dummy. Yeah, so that's another small thing, but anyway important that we hope to achieve.
Thank you for adding that. That is, of course, an important part of the project. So now I see that the time is nearly at the end of this extended workshop. So I will take the opportunity to thank you all presenters, of course, but also all those that has participated. It has been great to see that this has caused such an interest, and also thank you for all the questions that you have posed. I have been inspired. I hope that the same goes for all of you. And then I hope that, if not before, that we see each other in conjunction with the COBE in Munich 2021 instead of 2020, and there discuss where we take the next steps from where we are in a year from now. So with that, thank you all, and take care, and bye for now.
Thank you
very much.
Thank you. Bye.
Thank you.
Bye.
Bye.
Bye. Bye.
Bye.